I'm on page 36, and this time what we're going to do is the cart's here, and we're going to give the cart a push and stop the cart at the highest point up here. And it says answer the following questions for when the cart is coasting. So after I've finished pushing it and it's rolling up and it stops at its highest point. So I'll show you what that looks like. There's the cart. Give it a push, and I stop it when it gets to its highest point. Okay. One more time. Give it a push and stop. So the first thing I'd like you to do is I'd like you to pause the video and I'd like you to attempt the motion map yourself. It's really important, just like always, that you attempt it first and I'll go through the answers. So pause now. Okay, so what does this motion map look like? We're looking at the cart when it's coasting, and we know that when I gave it a push, it's going really fast. So at the start, here's my first dot, it's moving quite far, and then as time goes on, it slows down, so the dots get closer and closer together. So I like to draw on my velocity arrows, so it's definitely going this way, and those velocity arrows are getting shorter and shorter and shorter until they stop. Always I label them V, V, V. The next thing I do, I have to make sure I include both my velocity and acceleration vectors. Vectors, remember, just means arrow. So let's change color. I always do my acceleration arrows between two velocity arrows, and it's the difference. So if I was to, example, put an acceleration arrow like this, it would mean that, what happened there? It would mean that the velocity is here. This acceleration arrow would suggest that it's speeding up and this next velocity should be bigger. It's not, so we know that is not correct. Because this is slowing down, the acceleration arrow, because this is slowing down and the velocity arrow is smaller, my acceleration arrow needs to be in the other direction. The same thing here between these two. I've got acceleration arrow. These should be the same size, and between these two, an acceleration arrow. One of the things I haven't taught you yet, but I'll teach you now, is to show something that's the same size, you can put little equal signs on it, and equal signs on another one, and equal signs on the third one. That means all of those arrows are meant to be the same size. So I've got here my 0 mark, I've got my positive. Is the velocity positive or negative? The velocity is going to the right, which is where my positive is. The velocity is positive. Is the acceleration positive or negative? Well, in this case, the acceleration is going the other way, so it's negative. Okay, so coming down here, this is really important that you give this a go. Have a go at predicting what the graphs are. A position graph, a velocity graph, an acceleration graph. And I'll get you to pause the video now and do that, and then I'll run the experiment. So pause the video now. Right, so let's run this experiment. Hopefully you've done, well, not hopefully, you would have done your predictions. I've got this ready to go. I've got it on trigger, which means it just goes automatically. And I'm going to go now. Stop. Oh, beautiful. Right, let's zoom in on these graphs. The position one looks like that. It starts off near 0. It curves upwards. The gradient gets less and less steep. The velocity starts off high and it goes down towards 0. And the acceleration is negative the whole time. It's meant to be quite flat. So what does that look like on your graphs? That looks like, where's my pen? I like red. My position was started off steep and got less steep. My velocity was positive and it headed down in a straight line to 0, and my acceleration was negative the whole time. That makes sense because I've said my acceleration was negative up here. So pause this video again and answer the questions, and I'll go through them after you finish pausing it. So the slope of this position time graph is it's positive, and it starts off steep. There's a tangent there, and it gets less steep. There's a tangent there. So the slope is decreasing, and always the slope on this graph represents velocity. The slope of the velocity time graph, that's a negative slope, but it's the same slope the whole time. It's a constant one. And the slope of the velocity time graph always represents acceleration. That makes sense because a negative slope and I've got a negative acceleration. Great, thanks for the lesson. How do I pause this?